All right, so get this. We're diving into AI that could understand the world in a whole new way, like way different than anything we've seen before.
Oh, yeah.
It's this wild concept called quantum capsule networks.
QCapsNets.
Yeah, QCapsNets for
Yes.
short. And we're using Yorgo Snippet's essay, QCapsNets, quantum capsule networks for KI innovation, as our guide for this deep dive.
That's a great choice. It's a really fascinating area of research, you know?
Yeah, definitely.
Schnepphat's essay really highlights how these QCapsNets, they pull from both quantum computing and AI to potentially change how we process information at the most basic level.
Okay, so let's start with quantum computing.
Yeah.
I'll be honest, it always sounds a little bit like science fiction to me.
Right.
What are the fundamental ideas that make something like QCapsNets even possible?
Well, imagine the bits in our computers, like the zeros and ones.
Right?
But instead of being stuck in one state, they can be both 0 and 1 at the same time.
Whoa.
That's the building block of quantum computing. And it's possible because of this concept called superposition.
So instead of just on or off, a qubit can be in this weird in-between state.
Yeah, it's a strange idea, right?
Yeah. What does that actually do for us?
Okay, so think of it this way. You're trying to find a specific grain of sand on a beach.
Okay.
A classical computer would have to check each grain one by one.
Yep.
But a quantum computer, thanks to superposition,
Right.
could analyze all the grains simultaneously.
Really?
Yeah, it's a massive efficiency boost.
Wow. Okay, I'm starting to see the appeal. But what about that other quantum concept, entanglement? Schnepphat mentions it plays a role here too.
Right. Entanglement is where things get truly bizarre.
Okay.
It's when two qubits become linked,
Mm-hmm.
and their fates are intertwined no matter how far apart they are.
Whoa.
It's as if they have this secret communication channel. Einstein famously called it spooky action at a distance.
Yeah, spooky.
In the context of QCapsNets, entanglement could allow for stronger correlations between parts of the network, leading to a more sophisticated understanding of data.
So it's like these quantum bits can not only multitask like crazy, but also share information instantly across vast distances.
Yeah, you got it.
It sounds incredibly powerful, but also really complex. How do we even begin to build AI on this foundation?
That's where capsule networks come in. Think of them as an upgrade to traditional neural networks.
Okay.
Which, while impressive, they're not so good at understanding complex relationships within data.
Okay.
For instance, a traditional network might recognize a nose, eyes, and a mouth,
Yeah.
but not understand that they make up a face.
So they see the parts, but not the whole picture.
Exactly.
How do capsule networks change that?
Capsule networks use something called vectors, which are multidimensional containers of information.
Okay.
Each capsule represents a feature not just by its presence, but also its position orientation and other properties. It's like the difference between saying, there's a wheel, and saying, there's a wheel attached to a car spinning at this speed, tilted at this angle.
Okay. So it's a much richer, more detailed way of representing information. Much more nuanced.
But how does this all come together with quantum computing? How do we get to these QCapsNets?
Imagine taking those detailed capsules and encoding them as quantum vectors.
Okay.
Now you have a system that leverages the bizarre abilities of quantum mechanics. Each quantum capsule could hold information about multiple possible features simultaneously,
Yeah.
and they could communicate with each other through entanglement.
So it sounds like we're talking about a whole new level of AI, something that could potentially go way beyond what we've seen with traditional approaches.
Yeah, I think that's a fair statement. It's a whole new ballgame.
It's both exciting and a little bit intimidating.
I know, right? It's mind-blowing stuff.
But before we get carried away,
Sure.
let's ground this a bit. What kind of real-world applications could we see with QCapsNets? Schnepphat's essay mentions a few intriguing possibilities.
Oh yeah, there are tons of potential applications. Let's dive into those.
Yeah, one area that stands out is image and language processing.
Okay.
Imagine an AI that doesn't just recognize a cat in a picture, but it understands the context.
Yeah.
Is it sleeping? Is it hunting? Is it playing?
Oh, wow.
That level of understanding could revolutionize everything from self-driving cars to medical diagnostics.
So instead of just reacting to obstacles, a self-driving car powered by QCapsNets could anticipate what other drivers and pedestrians might do.
Yeah.
Based on a deeper understanding of the situation.
Exactly. And in medicine, QCapsNets could analyze medical images like X-rays or MRIs with far greater accuracy than current AI systems. It could be like having a team of expert radiologists constantly double-checking every scan,
Wow.
looking for those subtle signs of disease.
That could be a game changer for early diagnosis and treatment.
Absolutely.
What other areas does Schneepat highlight?
He also mentions the potential for QCapsNets in genomics research.
Okay.
Think about analyzing the complexities of DNA,
Right.
not just identifying individual genes,
Wow.
but understanding the intricate relationships between them. That could lead to breakthroughs in personalized medicine and a much deeper understanding of genetic diseases.
It's like having a superpowered microscope that can see not just the pieces,
Right.
but the entire puzzle of how our genes work.
Exactly.
Are there any areas where QCapsNets might not be as effective?
Well, it's important to remember that we're still very much in the early stages of both quantum computing and capsule network research. Schneepat is careful to point out that building stable and reliable quantum computers is a huge challenge.
Right. Those qubits are notoriously finicky.
Yeah, they are. What other challenges stand in the way?
Well, I mean, besides the hardware itself.
One is the development of efficient algorithms, specifically designed for QCapsNets.
Okay.
We need to figure out the best ways to program these quantum systems to take advantage of their unique capabilities.
So it's not just about the hardware, it's also about the software.
Yeah, exactly. It's a two-pronged approach.
Schneepat seems optimistic, though, right? What makes researchers so excited about the potential of QCapsNets despite these challenges?
I think it's the sense that we're on the verge of something truly transformative.
Oh.
If we can harness the power of quantum mechanics for AI, it could change everything.
Right.
From how we develop new drugs to how we understand the universe itself.
It's almost overwhelming to think about.
It is, right.
But this brings up another question. If we're talking about AI with this level of power and potential, shouldn't we also be thinking about the ethical implications?
Absolutely. As Schneepat points out, any technology this powerful requires careful consideration.
Right.
We need to think about how to ensure these systems are developed responsibly and used for the benefit of humanity.
That's a crucial point. But before we go down that rabbit hole, let's stick with Schneepat's essay for now.
Sure.
He doesn't go into specific ethical concerns, does he?
Not in detail, no. His focus is primarily on the technical aspects of QCapsNets and their potential applications.
Right.
But he does acknowledge that the ethical dimensions are important and will need to be addressed as the field progresses.
It's a good reminder that we can't just focus on the cool factor of new technology.
Right.
We have to consider the broader implications as well.
Absolutely.
But for now, let's return to the potential of QCapsNets. Schneepat touches on a few specific areas where they could be especially impactful, doesn't he?
He does.
Yeah.
He talks about how QCapsNets could revolutionize material science, for example.
Yeah.
Imagine being able to design new materials with specific properties,
like
lighter, stronger, more durable, by simulating their behavior at the atomic level.
Wow.
Using QCapsNets.
That sounds incredible. And I can see how QCapsNets could be a game changer for fields like drug discovery. Yeah. Where understanding complex molecular interactions is key.
Exactly. The ability to model those interactions with the precision and efficiency of QCapsNets could accelerate the development of new treatments for all sorts of diseases.
This is all very promising. But is there anything in Schneepat's essay that suggests how long it might be before we see QCapsNets actually being used in these ways?
He's cautious about making specific predictions. Yeah. Which is understandable given the challenges we've discussed.
Right.
But he does point to the rapid pace of progress in both quantum computing and AI research as reason for optimism.
So while we might not have QCapsNets powering our smartphones tomorrow, it sounds like we could be on the cusp of a major breakthrough.
I think that's a fair assessment.
Yeah.
And even if it takes longer than we hope, the journey itself is bound to be filled with fascinating discoveries.
Okay, so we've talked about the potential applications of QCapsNets, the challenges of developing them, and the ethical considerations we need to keep in mind.
Right.
Is there anything else in Schneepat's essay that you think is crucial for understanding this technology?
He emphasizes that QCapsNets are not just a faster version of current AI.
Okay.
They represent a fundamentally different approach to information processing, one that could unlock entirely new ways of understanding and interacting with the world.
It's almost like we're talking about a new form of intelligence, one that's based on the bizarre and beautiful principles of quantum mechanics.
That's a great way to put it, and I think that's what makes QCapsNets so fascinating.
Yeah.
They offer a glimpse into a future where the boundaries between the physical and the digital, the natural and the artificial, become increasingly blurred.
This has been a truly mind-bending deep dive into the world of quantum capsule networks.
It has.
All thanks to the insights of Yorgo Schneepat and his thought-provoking essay.
Definitely a must-read.
But before we wrap up, I have one final question. If AI can tap into the strangeness of quantum mechanics, if it can use, like, superposition and entanglement, what are the limits of its understanding? Could it develop ways of thinking that are completely alien to us?
It's a question that really pushes us to reconsider what we even mean by intelligence, you know?
Yeah.
Could QCapsNets develop forms of reasoning or awareness that we can't even begin to comprehend?
It's a bit unsettling to think about, but also incredibly exciting.
Right, it's a bit of both.
We could be on the verge of creating something truly unique. A new kind of intelligence that could help us solve some of the biggest challenges facing humanity.
Absolutely. And perhaps even help us ask new questions we haven't even thought to ask yet.
Oh, wow.
It's like we're standing at the edge of a vast, unexplored continent, and QCapsNets are our compass and map.
This has been an incredible journey into the world of quantum capsule networks.
It really has.
We've explored their potential to revolutionize AI, the challenges of developing them, and the mind-boggling implications of merging quantum mechanics with artificial intelligence. A huge thanks to Yorgo Schneepat for providing the intellectual fuel for this deep dive with his essay, QCapsNets, Quantum Capsule Networks for KI Innovation.
Definitely a fascinating read.
For those of you eager to delve deeper, we'll be sure to include some resources in our show notes.
Absolutely. And if you want to explore these ideas further, definitely check out Schneepat's essay.
Yeah.
It's a really thought-provoking piece that gets you thinking about the future of AI.
Absolutely. And everyone listening, keep questioning, keep exploring, and keep your minds open to the infinite possibilities of the quantum world. Until next time.